Hey everybody, and welcome back. Or if it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, what we're going to do is continue with the ISIS learning, i.e. the intermediate system to intermediate system routing protocol. Now, I've already done quite a lot of videos on this routing protocol, and I highly recommend that you watch those videos first before proceeding. If you haven't seen those, here's the link, or they're down in the comments box. But what we're going to cover in this video are three things. First, we're going to cover route redistribution. So we're going to go through how can we do route redistribution into the ISIS routing protocol. What do you need to do and configure on Juniper Junos devices to allow that to actually happen? And then we're going to go through second point, route summarization. You're going to see on the lab that we're really just going to basically configure 3 static routes and then export those via a policy statement into ISIS. Now, those 3 different static routes you'll see are going to be in different networks, different subnets. So just like any routing protocol, you want to do some kind of summarization to keep that routing table as small as possible. So we're going to go through how can we actually do that in the ISIS routing protocol. It's a lot more different than what you do in the OSPF world, where you've got that glorious area range command. We do not have that in the ISIS world. And then finally, third point, we're going to go into route leaking. If you've seen the other videos, and as we know, when you go from a level 2 network into a level 1 network, all those prefixes are not just sent into that level 1 network. What those ABRs, or area border routers, actually do is inject forward, transmit into that level 1 network a default route, i.e. 000.0/0. It's just a default route. So we're going to go through how can we actually do specific type of route leaking to allow some form of traffic engineering. So a lot of information to go through. So what I suggest is let's just jump straight on the lab and let's get going. And here's the lab, everyone, and let's just start with doing a quick recap on what's been configured so far. What are we actually looking at in terms of this network? Obviously, it's not a huge network, but all of this network is based on the routing protocol ISIS for obvious reasons. In terms of what we're looking at, obviously, we have got here 3 different areas. We've got area 0, we've got area 1, and we've got area 2. Now, if you've watched the previous videos, you would know that area 0 is, in the OSPF world, the backbone. Here it is the backbone, but it doesn't have to be area 0. In ISIS, you could have area 3, 4, 5, 100, 1000, whatever as the backbone. In the OSPF world, it has to be area 0. Here I've configured the backbone area 0 to be the backbone, just for consistency, just to keep things simple. But we've then got area 1 and we've got area 2 here. Now, both of these are the non-backbone areas. For obvious reasons, they are attached to area 0. Now, in terms of the levels, and again, refer to the other videos that I've done on the ISIS levels, in the area 0, the backbone area, everything is level 2. In area 2, everything is level 1. So we've got a level 1 connection here, here, and here, going between all these different routers here. In area 1, however, we have almost a mix of level 1 and level 2 connections. We've got level 1 here, we've got level 1 here between these different routers. But from VMX2 all the way down to VMX3, we've got both level 1 and level 2. So that doesn't mean half, it just means level 1 and level 2. Now, again, referring to previous videos, we know that all the networks in the non-backbone areas, i.e. area 1 and area 2, they are absolutely seen in that backbone area, area 0. So level 2 networks in the ISIS routing protocol will always see everything, unless you're doing some kind of firewall options, some kind of policies, obviously some type of route summarization that we're going to come onto in this video. The level 2 network, i.e. area 0 in this case, it's going to see everything. Whereas the non-backbone areas, areas 1 and areas 2, they do not see everything. And that is because from the backbone area, regardless whatever that area number might be, they inject, the ABRs inject a default route in both directions. And what that basically allows is all the routers in, or multi-layer switches in those non-backbone areas, i.e. level 1, to have a default route. So regardless of what the actual destination may be, they can use these default routes to basically get anywhere on the network itself. But as I said, there's 3 points to this video, and the very first one is route redistribution. Now, what I've actually done, just from a network lab perspective, I've just entered these static routes in here. We haven't configured anything yet, but what we're going to do is build on R8 here. We're going to build these static routes, so 192.168.1.0, 2.0, 3.0, and then we're going to import, or I should say specifically export, those static routes into the ISIS routing protocol. So R8 is going to build these static routes, it's going to export those into the ISIS routing protocols up to R7 and R8 here. Now these are the ABRs, and let me just tidy up the screen a little bit. So R8 is going to redistribute those static routes up to routers R6 and R7 here. Now these are ABRs, so R7 is an ABR, R6 is an ABR, R2 is an ABR, and R3 is an ABR, or area border router. Serves the same function as an ABR in the OSPF world, but slightly more different, because in the OSPF world they deal with LSAs. In the ISIS world we are dealing with PDUs. And again, if you don't know what the PDUs are, refer to one of the previous videos down in the comments box. But what we should see, and hopefully do see, is that these static routes which are being distributed into ISIS are then sent into that backbone area. And that's really the first test, is A, how do we do route redistribution into ISIS? But then from routers R5 and R4, do they see these static routes here? Do they have the visibility into it? And then that will go very nicely into route summarization and route leaking. So let's jump onto the Junos config, the CLI, and actually start configuring all this. Just logged onto SSH onto router R8. Now there are a few things that I initially just want to do. The very first thing is actually test, can we ping all the way from R8 all the way over to R1? Obviously we want to ensure come the end of really this video, after we've done the route distribution, summarization and route leaking, can these static routes here be seen all the way over here? But first things first, let's make sure that actually R8 can ping R1. Then I just want to make sure that have we got adjacency from R1 all the way up to R6 and R7, just the ISIS adjacency. So we're going to do a shell command for that. Then what we're going to do is build these static routes on R8 and then define a policy to export these policies into that ISIS routing protocol, and as I said, for them then to be distributed, i.e. advertised to routers R6 and R7. So first things first, as I said, let's test to ensure can we actually ping all the way from R8 over to R1. So let's just do a run ping 8888, and we can ping our own, so we just know that, you know, the virtual lab is running fine, you know, from R8. And now let's do the same command, let's do 1111, and we can. So we can ping all the way from R8 over to R1. Now the next command I want to do is just make sure, and I know that it's working because we've just done the ping command successfully, but I just want to make sure that I've got adjacency to both routers R6 and R7. So to do that, we just do a run show ISIS adjacency, spell it right, and now we can see that we've got the system R6, R7, both are level 1, state is up and out of these respective interfaces, so everything is looking good. Now I need to define those static routes. Now to do that we have to define a routing option. So if I go into edit routing options and just do a quick show, you can see the router ID there has been configured. There's no BGP ASNs. That's a video I'll be doing very soon actually. But we need to define those static routes. So let's do set static route, and you can see the static routes are 192.168.1.0,
2.0, 3.0/24. So I'm now going to do set static root 192.168.1.0/24. And if I hit question mark now, you can see we've got quite a few different sub commands that we can enter in. Now there's two that I really just want to highlight. First is the discard. So what this says is if a remote end, i.e. R1, when we do this at the end, tries to ping any of these IP addresses that would fall within these subnets, it is going to discard those ICMPs. It will not send a response. Now we do not want that in this case. In certain scenarios you may want the Junos to discard those packets, not send a response, so that external hackers maybe do not know that these networks actually exist. But what we want to do just for this lab testing and for verification, we want to do a reject. So what that's going to do is it's going to receive the ICMP requests, and it is going to send an ICMP response. And that way, when we do the ping from R1 all the way over to R8 with these static routes, after we've done the distribution, etc., we know that we've got that connectivity. Whereas if we'd done the discard, we just simply wouldn't know. So what I'm going to do now is just do reject. And that's it. I've configured my first static route. And if I just hit up now, I'm going to do the same for 2.0 and 3.0. And if I do show again, we have now got our 3 static routes. That's it. That is how you configure static routes in Junos. Very straightforward, very quick, very easy. But as I said, that's the first step. That is, all we've done is defined the static routes. We now need to export those into the protocol ISIS. But we need something to export it by. You just can't say in Junos, yeah, export these static routes. We have to define a policy statement. So if I do top, edit, policy options, policy statement, and I'm just going to give it a name called export static. And you can see I've immediately moved from that routing options branch over into the policy options policy statement, and it's actually created a new policy statement for me called export static. The name could be absolutely anything, but I've just kept it simple, kept it straightforward, export static in this case. So now what I'm going to do is I have to set specific terms with specific attributes and configurations. It's a policy statement at the end of the day. So I'm going to say set term 1, and if I hit question mark, you can see we've got the from command, the then command, the to command, i.e. from this static route, from this protocol, from this interface, from this route filter, whatever it may be. Then I want to take this action, or if it's going to a level, if it's going to a specific route filter. And you can see how you can mix and match these. There's a lot obviously we can do. So if I say from, and what I want to say is static, from protocol, static, and if I now do show, you can see it's already done that. So that's okay. We're saying, you know, term 1 from protocol static. Now we've only got 3 static routes here. There's no more. This is a controlled environment. It's a lab at the end of the day. In the real world, in a production network, you're more than likely going to have quite a few static routes. And we need to be quite specific here in terms of what we want to filter by. We want to filter specifically for any static routes with 192.168, 1.0, 2.0 and 3.0 exactly. So if I just hit up twice, I'm going to say now from route filter, and I'm now going to filter down on specific network. So I'm going to say 192.168, 1.0, and if I now hit question mark, you can see I've got the term exact. So it's going to exactly match that prefix length. I might just want to do a /24 actually and do exact. Now if I do show again, you can see that we are filtering on all static protocols, but with that route filter of 192.168, 1.0. I need to do the same for 2.0 and 3.0. And if I do show, that's great. We've now been a lot more specific with what we want to actually filter by. But we also need to say something else. We can't just say from these filters. We now need to say set term 1, then except. So actually, if I just go back and hit question mark, you can see there's a lot that we can then do when we hit the then command. So we can do specific analysis. We can put a class of service on this, maybe some kind of coloring. We could do damping for BGP. We could set a specific next hop. There is a lot that we can actually do. But all I want to do here is say then accept. So if I do show now, you can now see from all static routes which fall within exactly the 192.168.1.0, 2.0 and 3.0, I want to accept these. Now if I just do a quick commit on this, and you can see that as committed successfully, of course. Now let me just go back to the top. Now what we need to do is this third and final part in terms of the route redistribution. And let's just do a quick summary so far. We've created the static routes. We've created the policy option, the policy statement, which is going to take specifically exactly those static routes and do something with it. I accept. Now we need to apply that policy statement, which is filtering on those static routes. We need to export that into ISIS. So ISIS knows what it's exporting. So if I go into edit protocols, ISIS, do a quick show, you can see all the configuration from the previous video. So we've got the interfaces, we've got the reference bandwidth, we've got level 1 wide metrics only. Again, if you want to see what these actually are, the videos are linked to the comments box down below. But what I just want to say here is set export, and if now if I hit question mark, you can see there is that policy statement that we just created and committed into the running configuration. Now if I do a quick show, we can actually see it is right here. Export static, really happy with that. So now if I just do commit, and that has committed it successfully. Now all I want to do now is go onto routers R6 and R7 and see, do they actually have visibility, do they have in their link state database for ISIS these static routes, because these are all in the same area, they're all in level 1. So let's go into R6 and let's do show IS. Oh, you have to do the run command. So actually what I'll do here is actually quit. Let's do show ISIS question mark, and I want to look at that link state database. So let's do database, and now what we can see is all the PDUs, the protocol data units that I'm getting at level 1 and level 2, because this is an ABI, it's bordering both level 1 and level 2. And again, referring back to previous videos, ISIS has 2 link state databases, one for level 1, one for level 2. Now I want to look specifically into the R8 PDUs, which you can see just here. So what I'm going to do is I'm going to show that again, but I want to filter onto a specific system ID. So I'm going to do R8.0200. So let's just do, I could have done a copy and paste, would have been a lot easier. So let's do 0200, and I want to do a detailed view on this. Or what I could actually do is just do show ISIS route, and now what you can see is the 192.168.1.0, 2.0 and 3.0. So that's great that we have configured those static routes, we have configured that policy statement to export those static routes on R8, and because we've exported that into ISIS, R8 is advertising these networks that we've just created to R6 and R7. Let's actually go on R7 and ensure that it can see these as well. On here, let's just do a quick run show ISIS route and scroll down, and we can see we've got those networks right here. So everything is working great. Now the real question now is, can R1 ping one of these addresses, one of these networks, and will it get a response? So let's go on to router R1, and I'm just going to quit out of here and let's just do a quick ping 192.168, let's just do 1.1 just for example, and immediately we know that's working. It might not look good because you'd be expecting some kind of packet response in terms of delay, etc., that you typically get with a ping, but what we're getting here is destination net unreachable from this next hop interface, which is somewhere in the network without me looking at where that IP address actually exists. But this is exactly what we configured on our R8, because we defined that route option, static route, to be reject. It's sending an ICMP response and saying, yeah, this destination right here, it's not reachable. If we actually define that to be discard, we wouldn't be getting this. So we know that R1 can get to these networks all the way across this ISIS routing domain. But if I actually just do show ISIS route, you can actually see it does not have in its routing table for all routes received from ISIS the 192.168.1.0, 2.0 and 3.0. It's got that default route 000.0/0. That is injected from the ABRs, area border routers R2 and R3. Now as we move forward, route summarization and into route leaking, this is going to change, particularly in that route leaking phase. But first let's just actually talk about route summarization.
So route summarization. As we've seen, we've created these static routes here on router R8, and we have exported those successfully via policy statement onto R8, but that has gone all the way over to R7 and up to R6 via the protocol ISIS. However, what we would see from the routers in the backbone is that each one of these routers, so routers R2, R3, R4, R5 and even R6 and R7, they are going to be seeing all of these networks here. Now whilst that might sound of a benefit because it's full visibility, it's really not, because at the end of the day ISIS, just like OSPF, is a link state running protocol. It uses the Dijkstra algorithm, if I say that correctly. I think if I spell it, it's DJIKSTRA, Dijkstra. I think I spelled that right. But this is the shortest path first algorithm. Now, if we put this into perspective, what that means is that R8 is advertising the free networks down here, the free networks up here. And then those ABRs are advertising ×3 those routers down here. Sorry, those networks down there. ×3 across here. ×3 across here. ×3 across all the way up here. And it does the same all the way across here, across there, across here, and up to there. Obviously, this is a full meshed network, but this isn't great because if one of these links starts flapping, say the 192.168.3.0/24, say it starts flapping, that is going to cause a huge SPF rerun. It's going to cause all the routers here to do that SPF calculation on what is the shortest path to get to that destination, because it's flapping, it's going up and going down, going up and going down. So obviously we don't want that. What would be beneficial for these static routes is maybe conduct that summarization at routers R8, but in my opinion, we want all the routers here in this area to have visibility. Or you could actually say, well, we might as well just do summarization all the way at the edge. It is a little bit of a debate, I know. But what we're going to do here, just for practice, is actually we're going to do that summarization at the ABRs, because here's where we inject routes, prefixes, advertisements into an area and out of an area. So for me, it makes sense to do it at the ABR. So we are going to define the policy statement at the ABR R7 and at the ABR R6. Now, unlike OSPF, where we had that glorious area range command, we do not have this in ISIS. In OSPF, what we did is just basically say, yeah, area range, point towards an area, and any contributing routes, networks that fall within this and are active, we're going to advertise it. As long as there's one contributing route, we're going to advertise that area range. It's basically a summary address. In ISIS, we do not have this. What we have to do is define an aggregate route. So what we're going to do is we're going to define an aggregate route which is aggregating, summarizing that 192.168.1.0, 2.0 and 3.0 into a single summary address. So that's step one. First we have to define that aggregate address. The second step is, again, we have to define a policy, just like we did with the static routes. It is all well and good defining static routes, or in this case, an aggregate route, but then we need something to do something with it. We need to define a policy statement which is going to take the aggregate route, accept it, reject it, do something with it, and once that's defined and committed, we can then export that into that ISIS routing protocol, specifically at the ABRs R7 and R6 here. So let's actually jump on the ABRs and start configuring this. So here we are on router R6, and just to recap, if I just do it's in capitals, if I do a show ISIS route, we can see we have got the 192.168 1.0, 2.0 and 3.0. Now we're doing the summarization on these ABRs, so we're not going to see it condensed at the really in the backbone in area 0, because we're conducting the summarization on these particular routers themselves. But first it's going to configure mode, and we need to configure that aggregate route. So let's go into edit routing options. Let's do a quick show, and you can see that I've got my route ID there but nothing else. Now I need to define that aggregate route itself, and I just realized I didn't actually put up or say what that summary address is. So it's 192.168.0.0/22. so basically the 192.168.1.0, 2.0 and 3.0, those are contributing routes which are going to be summarized as an aggregate route into 192.168.0.0/22. So moving back onto router R6, we need to define the aggregate route. So let's say set aggregate route 192.168.0.0/22. Now if I hit enter on this and then do a show, we have now configured our aggregate route. So that is the first part. Again, we need a policy statement which is going to take that aggregate route and do something with it. So now we need to define that policy statement. So let's just go to the top, and it's going to edit policy options, do show, and you can see that there's nothing configured here. So I'm going to do edit policy statement, spell it right, always a good thing, and I'm just going to do some for summarization there, just for simplicity and keeping it short and sweet. Now, just like we did on router I, we have to define a term. So I'm going to say set term1 from protocol aggregate, and I can also do a route filter at this point. However, what I just want to do initially is just say I want to look, if I do a quick show, I just want to accept from the protocol aggregate. Now what I'm going to do is set term2 from route filter 192.168.0.0/22 longer, set term2 then reject, do a quick show. And you can see we're starting to build what we actually want, but we're not fully finished just yet. And I just realized as well, I forgot to do the set term1 then accept. So let me just enter that in, and now that it's saying term1 from protocol aggregate then accept, term2 from route filter 192.168.0.0/22, or, well, not or, longer. So anything longer than that network and that subnet mask is going to be rejected. But that is not specific enough. We need to define for term2 what protocol as well. It could be coming from ISIS, it could be coming from RIP, it could be coming from OSPF, it could be coming from BGP. We have to be very specific here. So I'm going to do set term2 from protocol ISIS. And if I do a quick show, we can now see we're starting to get even more specific. But we can still get more specific than that. We can now say set term2 from a particular level. So if I do set term2 from level, hit question mark, and now I can enter in the ISIS level. Now these networks, i.e. 192.168.1.0, 2.0 and 3.0, they're coming from level 1. So I need to define level 1 here. And if I do a quick show, again, now that is very specific. We are saying term1, I want to accept all aggregate routes. I could define a filter here, but there's no need to. I want to accept these aggregate routes. But term2 is defining if it's the protocol IS and from level 1, which it is, anything that is longer than the 192.168.0.0/22, then I'm going to reject those. Because 192.168.1.0, 2.0 and 3.0, they are longer than this 192.168.0.0/22, we are just going to reject that. But at the same time, we're advertising in that aggregate route. That is, if I do top show routing options, we are still advertising in this particular aggregate route, because we said here protocol aggregate, accept it. So we're accepting this in, but anything that's longer than this, we are rejecting it. So if I just do a quick commit on this, and that has completed. Now the final part in this route summarization is to take that policy statement and do something with it. I export it into ISIS. So if I go into Edit Protocols ISIS, do show, we can see all the previous commands, but now I just wanted to say export sum, commit this. If I spell it correct, it always helps. And that has committed successfully. Now that is just on router R6 here. We need to do the same on router R7. Otherwise, these static routes here, they're not being summarized to R7 and they're still being advertised into that backbone. And you're going to have all the limitations of if a link goes down, starts flapping, whatever it may be, all those SPF reruns, those recalculations, just because of a link flap, and it's not particularly the best, and you're taking up more room in the link state database as well. So we need to go onto router R7 and do really the same thing. So let me just make this a bit larger, and there we go. So just for quick confirmation, do I have those routes? We can see we've got those routes just here, the 192.168.1.0.3.0, and I have no idea where that's coming from. Oh, that's because it's coming across from R6. So you can already see that's actually working because this is a level 1 connection here. The router R6 is already advertising, hey, I've got 192.168.0.0/22. So yeah, that does make sense. So we need to define that aggregate route. So let's do set routing options aggregate route 192.168.0.0/22. And I forgot the route, and there we go. Now I need to define that policy statement. So if I do edit policy options policy statement, I'm just going to give it the same name, and it's to set term 1 from protocol aggregate, set term 1, then accept, and just do a show on that. That's the first term. Now I'm going to do set term 2 from protocol ISIS from level 1 from route filter 192.168.0.0/22 or longer. Well, longer I keep saying, or longer is actually no command, so I'll just make that clear. I'm trying to say longer. Set term 2, then reject. Let's do show, and that is it. That again is the exact same configuration that we just done on R6, now on R7. And I'm going to commit this configuration, and that's now completed. But just as we did on R6, we've configured the aggregate route, we've configured the policy statement to accept that aggregate route, but reject all networks that are longer than the aggregate route. We now need to export that policy statement into that protocol, i.e. ISIS. So let's do top. Let's just do quick set protocols ISIS export question mark. We can see it's there because it's been committed. If I now do show protocols, we can see it is right here. So I've already I've committed it, but we have that policy statement ready to be committed for ISIS. So let's commit the configuration, and that is now completed. So we have just done that route summarization on the ABRs R6 and R7. The real test now is, does the backbone area 0, doesn't have to be area 0 in ISIS again, but do R4 and R5 actually see this summary address, or do they still continue to see these different independent individual contributing networks, that is the 1.0, 2.0 and 3.0 networks? So let's go on route to R4 and just do a run show ISIS route, and there you go. You can immediately see we've got 192.168.0.0/22. It's at level 2 version 42. The metric is 110. It's internal, and you can reach it via the GIGI 007, which goes to R7, and the GIGI 006, which goes to router R6. That's perfect. So that is router R4. Do we see the same on router R5? Let's just do a run show ISIS route, and again we can see that summarized address there. So just by doing that, defining the aggregate route, defining the policy statement to take the aggregate route in and accept it, but reject anything that's longer, and then exporting that policy statement into ISIS, we have then got all the benefits with a summary address, i.e. no excessive amount of SPF runs just because of a link flap, a smaller link state database, which is always a lot more beneficial for troubleshooting. So that is route summarization. However, if I go on to router R1, and it's just here, and do a show ISIS root, then again, as we saw before, we don't see the 192.168.0.0/22 because they're being summarized at these APRs. Now we're not going to see these individual networks. Can we still ping all the way across? So let's do ping 192.168.1.1 just for example, and absolutely we still can. So it absolutely still works. But what if you want to do some kind of root leaking? And that is the next topic. So here we go, the final topic, root leaking. What is root leaking? Well, first let's look at it from area zero's perspective. As we know, all the connections in that backbone in this network area 0 are the level 2 connections. And we've even got a connection going between routers R3 and R2, which is a level 2 connection as well. They're all level 2 connections, whereas those that are a non-backbone area all have level 1 connections. So we've got level 1 connections here and level 1 connections all the way over here as well. Now the importance of this is that the backbone area 0 absolutely sees everything. It sees all. So all the networks in area 0, all the networks in area 1, area 3, area 4, and all the other areas there might be, it sees everything. And all those routes and networks are injected via the APRs into that backbone. But when we go in the opposite direction, when we're coming from area 0, the backbone or the level 2 network, to a non-backbone area, in this case from area 0 into area 1, we do not have all these networks here and all the way in here advertised into area 1. That is why the link state database of level 1 networks are a lot smaller. And ISIS always works really hard to separate level 1 from level 2. In additionally, and as I discussed earlier, the APRs R2 and R3 will inject a default route from area 0 into area 1, from level 2 into level 1. And this basically allows R1 to load balance. It's going to send packets down this way, and it's also going to send packets up that way. It's just doing load balancing based on a particular hash algorithm. Now, what if you wanted to do some kind of traffic engineering? So I'm just going to clear up the screen a little bit. And there we go, it's a little bit better. I don't want to clean it up too much. But what if you wanted to make R1 prefer this route here to get to these networks all the way over here? And again, remember, we summarized them into 192.168.0.0/22. So what if we wanted R1 to take this route into that backbone instead of this route down here? Well, that is where route leaking comes into it. On the APRs on R2 and on R3, but mostly on R2, what we're going to do is configure a policy statement which is going to define any routes which are coming from level 2 and are going to level 1 and match a particular route filter. We are going to accept that, and then we're going to import that into that protocol ISIS. So it's all around traffic engineering. It's all around allowing routers in that non-backbone area, in this particular example, in this particular case, to prefer a particular route over another route. Now, just for example, say that policy on router R2 fails. For whatever reason, someone deletes it, whatever it may be. That's okay, it will still work because the APR R2 is still injected into that non-backbone area, area 1, that default route. And again, it would then allow R1 to do that load balancing. However, in this particular case, we want to engineer traffic to go specifically from R1 to R2 and then through the network wherever it, well, not there, but wherever it actually may go. And so here's the command line interface on router R2. Now, do we actually have that 192.168.0.0/22, that summary address that's been advertised by router R6 and R7? So if I just do quickly show ISIS routes, then what we can see is that we do see it 192.168.0.0/22, and we could get to this via the GigE 004 and the GigE 005, which is going to R4 and R5 respectively. So that's great. Now that is the address, that's the summary address, summary route really, that we want to summarize. Now to do that, as I said, we need to create a policy statement. So to do that, I need to go into configure mode. I need to do edit, policy options, policy statement, and I'm just going to call this root leak for obvious reasons. And it's immediately created that. Now first I need to say set term 1 from level 2, set term 1 to level 1. So if I just do a quick show on that, then what we're saying here is that all routes that are coming, all networks, all advertisements that are coming from level 2 and are destined to level 1, and that's it. Basically that's everything that we've defined so far, quite literally nothing more than that. So obviously this needs to be a bit more specific. So if I was to say set term 1 then accept, that's great, because now we're saying, well, everything from level 2 that's going to level 1 then accept. But that's not so great, is it? Because we don't want R1 to see all the network interfaces and networks, etc., that are between all the different routers in area 0, and also all the way from between routers R6 and R7 and R8 in area 2. We don't want that. So we need to be a little bit more specific. So now I'm going to say set term 1 from root, I always do that, root filter, and I want to look for 192.168.0.0/22 exactly. Now if I do a show, that is a lot more precise, because we're saying the route which matches exactly 192.168.0.0/22, which is coming from level 2, if it's going to level 1, then I want to accept this. Now what I need to do is actually go into the ISIS configuration and do that. So I'm going to do top edit protocols ISIS. Let's do a show and we can see all the configuration that has been configured in the past. So can we do this at the interface level? So I've got the Gigi 001, which is going to R1. So let's just try this. I'm experimenting here. Set Gigi 001 .0, and let's see if there's an export option. Let's hit question mark. No, there's not. So you can't do it at the interface level. We've got to do it at the protocol level. So let's do set export, hit question mark, and there I've got my root leak. Hit enter, and I'm going to commit this configuration, and that's committed. Now the final test is if I go onto router R1 and do the show ISIS route, we can now see I'm getting the default route of 0.0.0.0/0 from both R3 and R2 out of these gig interfaces, but now I'm seeing the 192.168.0.0/22, but only coming from R2 out of the Gigi 002 interface. That's perfect. That's how we do route leaking in the ISIS world. So if I do a show route, then what we could see is all the routes, and here I've got the 192.168. Where is it? Sorry. Well, here I've got here it is here. So I've got the 192.168.0.0/22 with a metric of 163 because we have enabled the wide metrics. Video to that down in the comments box. But if I also just do a show ISIS database extensive and scroll all the way down to the bottom, you can see this. It's not highlighted because for some reason my secure CRT is not working today. Never mind. But look at this, 192.168.0.0/22 coming from R2. Yeah, we know that with all these costs. But here, this gave me a pause for concern, down. That is an interesting word, isn't it? Down, because when you read that, when you see that, you think, oh, hang on, that's not good. Something is down, something is not working. That's not actually what's being said here. That's not actually the case. This is what's known as the up-down bit. So this actually doesn't make sense in itself, because here we're saying, here the link state database is saying down, but we actually just saw somewhere back up in the root table here it is here, that is actually in the root table. If the root was down, if the link was down, it wouldn't be in the root table, would it? But we're still getting down here. So what is this down all about? And as I said, this is the up down bit, and this is actually a loop prevention mechanism in the ISIS routing protocol. So if we look at it from this perspective, we have got these summary addresses coming in here and here at the end of the day. I won't draw the arrows, but you know where I'm going. And by default, we don't leak the level 2 routes into level 1. No, we inject that summary route. I'm just going to do 0/0 for abbreviation. We inject that. So by default, we don't inject level 2 routes into level 1. But now we are. Now we've configured level 1 route leaking. And that 192.168.0.0/22, it's coming to R1, but then R1 is advertising it down to router R3. Wouldn't then R3 advertise that back into area 0? Yes, it would do without this up down bit actually here. This is what it's about. When this bit is set, router R2 is basically saying do not advertise this back into the backbone, whoever the other ABRs actually may be, because if you do that, if you advertise it in there, then these routers here are going to see, I can get to 192.168.0.0/22 via this interface as well, and it's going to send all its traffic through here, maybe through here as well, and before you know it, you've got a nice big loop going on, or even bigger than that. So this is a safety mechanism, it's a loop prevention mechanism where the ABRs will not inject back into area 0 or that backbone area, whatever it may be, that advertised leaked route. Loop prevention, that's all it is. So when you see this, don't be concerned, it's not a route is down or link is down, it is that up down bit. And so that's the end of this video, everyone. I hope you found that useful. I hope you found that informative. We've gone through a lot of information from the route redistribution, the route summarization, and also the route leaking, all within that protocol ISIS. As we've seen throughout all these videos, ISIS is a very powerful, efficient, and scalable plus future-proof router protocol, especially when you compare that to OSPF because it uses those TLVs. Now when we start doing route distribution, route summarization, and route leaking, yes, we're going against the default behavior of ISIS, especially when it comes to route leaking, but it's still capable of doing that, but in a slightly different way to the OSPF routing protocol. So once again, I hope you found that informative and useful. If you like this video, please give me a thumbs up, please subscribe. Any comments, feel free to write them down below. I really do like hearing from you guys, even if it's a private message. Other than that, thanks for your time and stay tuned for the next video.